And also I have started on the parts on basic concept in structural analysis. So structural analysis, which is the main thing that will be involved, will be covered in theory of structures. So the basic concept. So we have started on the basic concept. So these basic concepts, as I have mentioned many times in yesterday lectures. Some of the basic concept you have studied in EAS151, EAS152, which you need to refresh again and get the concept correct, because you will need this for the remaining of this course and also for the coming course EAS254, and for the rest of when you do design, when you do analysis, those basic concepts must be correct. Okay. So we talk about structural idealization. Structural idealizations, if you then look at the name, we idealize something. What do we idealize? We idealize the actual structures that has been built or we are going to build by using diagram. And we use analysis model. And we use analysis model to idealize it. And today I would like to go through a little bit more on some basic concept, some of the terms that you might be you might be encounter when you are looking at other references. I think first I want to start with concept of planar problem. Planar problem. This is the type of problem that we are dealing with. It is a planar problem. So what is a planar problem? So planar problems, I first show you, this is the structures that yesterday I show you this structure, vertical members, horizontal members, and this is a piece. In one piece, this is called a slab, column, beam. So all together form these supporting structures of the slab, and the slab support this water tank up there. So these are how actual structure will look like, and another one is structure like this. So you have column, beam, and all this together, column and beam, they form what we call a frame and support this floor here, which we call slab. So the actual structures, as you can see, they are 3D. They have length, they have width one direction and width the other direction. So this is how actual structure look like. They are 3D, three-dimensional. You have column here, okay? You have column in these directions. You have column here, column here. You have also in this direction there are columns. But in analysis, we do a lot of idealization, which is justified and correct, is not going to give you inaccurate result, which is justifiable in order to simplify the analysis without sacrificing the accuracy of the result. So in this case, if we look at these structures, we have column here, column here, column here, which stay in this plane here, and also we have column here, column here, column here, and also beam, which stays in this plane. So if you can see the axis X, Y, and Z, if you put the axis, so these members here stay in Y, Z plane. So this one stay in X, Y plane. So this is where the concept of planar problems come from. So planar problems is a problem where you idealize the structures, actual structures, into members which stays in different planes, and you analyze them separately. And as shown here, you take out this one, but knowing that it is connected to the other groups of members in the other plane. So in doing analysis, we must consider that. So if we consider that, knowing that fact, then you can use this analysis model to analyze what is going to happen to the forces inside this member, this member, what are the reaction forces here, for example. So this is what we call a planar problem, it is actually representing the real structures in different plane. The real structures is made of members in different plane. There are 3D structures, but for analysis, we do not need to, in many cases, we do not need to consider them as a whole 3D structures. We can simplify them without sacrificing the accuracy of the result, because that will make the calculation easier. Okay, so this is planar problems, or sometimes we call it 2D problem or 2D frame. So these are frame, okay? Vertical member, horizontal member connected together to form like a grid work like this. We call it a frame. So another example of actual structures, this is typical roof structures. Roof structures, so if you happen to drive by or see construction site when they are building the roof, you will typically see these kind of structures, which is used for supporting the roof. So there are many of them here arranged in rows, one here, one here, one here, and one there. And there are other members which is arranged in other directions to hold them together. So they form a whole structures in 3D, and the whole structures in 3D. For these structures also, we can idealize them into a series of planar structures. So this is, again, I simplify this is not actually not the same, but basically you have rows of these structures, a row of these structures, and they are connected together by members in other directions. So they form a whole roof structure which is 3D. But for this case, we do not have to consider all these things in analysis, because this will make the analysis very complex. And we can simplify them by taking one of the truss, one of these members. This is what we call truss. We can take one of these out, but remember that this is part of this whole roof structures, so we have to take that into considerations. And then we can then consider the load acting on these truss structures and analyze this as a 2D problem. So this is another example of 2D truss, but it is part of the whole structures which is actually 3D. And we can take this out because of the nature of the problem and without sacrificing the accuracy of the result that we are going to get. Of course, I have to emphasize here, there are some problems where we cannot do this. There are some problems that we cannot do this, and we have to analyze it as a 3D structures. But in EAS253 and EAS254, these are the types of problems that we are going to deal with, which is a 2D problem. Plane truss, this is one type of structures that will be covered. Plane frame. So everything is a planar problem, 2D structures. In planar problems, all members apply loads, including the applied loads, load that is acting here, represented by all these arrows here, and reaction forces lie in the same plane. Okay, in the same plane. For example, if you have a planar problem in XY plane, so everything lies in the same plane. And all movements in the direction perpendicular to the plane are restrained. So when we are analyzing this as XY plane, the problem in XY plane, so every movement which is perpendicular to the plane are restricted, meaning that this frame here, as I show here, cannot move in Z directions. Cannot move in Z directions. So anything that movement which has to do with the direction perpendicular to the plane are restrained, meaning that they cannot move. They are not allowed to move in that directions. So this is one of the characteristics of a planar problem. It can be plane frame, it can be plane truss, it can be plane arch. Okay? So the important thing is they all stay in the same plane. So that is a planar problem. So this is the problem that we are dealing with. But remember, planar problems is actually we idealize from the actual problem which is 3D. So it's important to take that into considerations. Remember that thing. Now we want to revise a little bit on what you have covered, what you have learned about support. Support structures cannot be just floating in the air. Actually, at least on the earth, when you're building structures on the earth, it has to be supported, and there must be a support. And also, structures are connected by different members. Different members are connected together to form a structures. Okay, so connections are necessary. We need connections. We need connections. Then structures, so supports are connected to the foundations, and connections are connecting different members. Connection are connecting different members. So there are three common types of connection or support. Connections, we can also consider them as a kind of, whether it is connected to the ground or connected to between two members. So there are pin connections, roller connections, and also fixed or rigid connections. So these are the three main types that we are dealing with. So these are example. I think what is important for us to know is, I have added this, I think, to show you that this is actual connection. So one member, vertical member connected to horizontal member, connected to vertical member, and another direction, horizontal member connected to another horizontal member. So these are connection. Okay. And also here another view of the connections, slightly different look. Okay, so they have different characteristics that we need to know. Characteristics of different types of and supports. So characteristics here we means what kind of movement is allowed and what kind of movement is not allowed. Movement that we are talking about is translation, moving left to right, moving up and down. This is translation. Rotation is it able to rotate relative to each other? Okay, can they rotate, or they are not allowed to rotate? Okay. So these are where connections are. Connection. These are connections, a pin connection, rigid connection. This is a rigid support. This is a pin support. The symbol that we use here. So we have to familiarize ourselves also with the common symbol being used, okay, for connections and support. So reactions at the support will happen when certain movement is not allowed. A pin support reaction in the form of forces, H and R here, these are forces, will happen. Reaction in the form of forces. For example, how many kilonewton will happen when movements or translations are not allowed. Restraints mean you don't allow them to move. But if at the same time you also restrain the rotations, they are not allowed to rotate here, no rotations. They are not allowed to rotate here, then you have moment. So remember class, when some movement is restrained, then you have reactions. Reactions happen because it is certain movement. It can be translations, moving left and right, moving up and down, or rotation. Restraint, not allowed to happen. So if translations or rotation are allowed to happen, you do not have reaction forces. So these are the things that you should know. I think that because we have learned this, so number of reaction at the support of pin, there are 2. Number of reaction at the roller, there are 1. Number of reaction at the fixed support, there are 3. So this one, keep in mind class, remember these basic things, 2 for pin, 1 for roller, and 3 for fixed or rigid. And we have to also remember for the case of, for example, in roller, where is the direction of the support? Now, these are I try to show here restraint movement which is allowed. Yeah? Movement which is allowed. If you refer to the notes, I have separated this. First, movement which is allowed. These are movement which is allowed. Rotation allowed. Translation in this direction allowed. In the direction of the plane of the support. So normally we use roller like this. We put a roller like this, and or we put this like floating in the air, meaning that this also in some books they use this symbol. And the supporting plane, the support plane here can be horizontal, it can be vertical, it can be inclined. It can be inclined in different orientations. And regardless of whether it is the supporting plane here is horizontal, oriented vertically or inclined, so the movement parallel to the plane of the roller support is allowed. You can see this arrow means they are allowed to move like this. They are allowed to move like this now. Yeah, the movement parallel to the plane of the support. And this, when you incline, the movement parallel to the plane of support is allowed. And rotation is allowed. And what is not allowed is here. Then I include here not allowed, a movement which is not allowed. So in the case of roller, translation perpendicular to the plane of the support is not allowed. Here, not allowed here. Here, so the plane is vertical now, so the movement which is perpendicular to the plane of support, which is this direction, is not allowed. And here, because the plane is inclined, so this is allowed, this is not allowed. But rotation is allowed. Because this is not allowed, then you get reaction like this. Reaction, 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 reaction in the direction perpendicular to the plane of the support. In the direction perpendicular, okay? In the direction perpendicular to the plane of the support. In the direction perpendicular to the plane of the support. So next, pin. Same thing, I show you what is allowed. So pin, only rotation allowed. Only rotation is allowed. Rotation is allowed, rotation is allowed. So pin symbol here, no more roller. So the tire here are removed now, no more roller. Or we put a circular symbol embedded into the support symbol here. So this is representing pin. It can be, again, oriented horizontally, vertically, or inclined, So rotation allowed. Next, I superimpose, which is not allowed. So the blue color, not allowed. So now you have translation, both direction, not allowed now. Here, direction parallel to the plane, not allowed, perpendicular, not allowed. The same thing here, look at the blue arrow here. So all these translation not allowed now, or restrain. Sometimes we use the word restrain. Restrain means is you prevent it from moving or from rotating. So the same thing here, not allowed. And not allowed, and here not allowed now, here not allowed, this direction not allowed, this direction not allowed. So when it is not allowed, remember class, then you have reaction force. That's why reaction force, we have reaction force like this happening, one pair. So there are two reaction forces, and as shown here, they are acting in the direction like this. The third one is everything not allowed. Okay, fully restrained, translation not allowed, cannot move left and right, cannot move up and down, cannot move left and right, cannot move up and down, cannot move in these directions, also cannot move perpendicular to the plane. Not only that, rotation also not allowed. So this is the most severe. The most severe restraint. Everything is not allowed at that support there. So because they are not allowed, then you have three reactions. Two are forces. One is moment. Here. One is moment. So these are the things that class you have to keep in mind. I think this concept of reactions that happen at the support, why they happen there, keep it the concept correct, so that when you draw free body diagram, when you do analysis, you do not forget the forces that you should consider. For example, in the fixed support, If you forget this moment, then the rest of the calculation is sayonara. Everything is not correct if you forget one of the reaction forces. So get this concept correct. So now let's see, let's just do a very simple example. So this one. Let me go back to this.